Okay, welcome. I'm going to do number 10 from the lesson that's on rectangles, rhombuses, and not rhombuses, they're rhombi, and squares. So hopefully this will help. This is one that you guys need to do. All right, let's go to the whiteboard. And before we do that, I'm going to turn off my video. Okay, here we go. So on 10, they give you some stuff on graph paper, and so I'm going to get a sketch of what they've given us. So for number 10, we have this coordinate plane, and at one corner we have U. At this other location here we have S, and then over here is M, and down here is C, and this makes what we are given. It says graph the quadrilateral USMC with coordinates 1, 1, 4, 5, 9, 5, and 6, 1 on the grid below. So we would start out with this graph. Now, you know what? I think I'm going to do this just slightly differently. So I'm going to take the picture away and I'll put this back in a second. Here's what I'll do. I'm going to create some of the grid just so I have it for reference. So I need to go out to about 8. Well, about 9, I guess. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And vertically, I'm not going to need to go more than about 5. 1, 2, 3, 4, 5. We'll go up to 6. All right. So 1, 1 is where U is. So this is a quadrilateral. Let's get the word quad in there, and it is quadrilateral USMC. U is the point 1, 1. S is the point 4, 5. M is 9, 5. C is 6, 1. So 1, 1 would be right here. 4, 5. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5. 4, 5 is, if I can get it estimated in about the right place, that's where S would be. And then M is 9, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9 over, and 5 up is just as high as the previous point. So that's M, and then C is at 6, 1. So 1, 2, 3, 4, 5, 6, 1 right here. All right. So we've got the quadrilateral. I'll draw this in. And part A is verify the quadrilateral USMC is a parallelogram by finding the slope of each side. All right, so this is a verify that it's a parallelogram. We know things are parallel, or when we know something's a parallelogram, it means they have parallel sides, opposite sides are parallel, and that runs in both directions. If opposite sides are parallel, like this, and opposite sides this way are parallel, if that's true, then you know it is a parallelogram. And so that's what we're trying to show, is that these are parallel lines, and the way to show that would be compare the slopes. And if the slopes match, you have parallel lines. Okay, there's a couple different ways to calculate slopes. Just a quick note over here. If we're doing slope, that could be change in y over change in x, and you can count that. Like rise over run is how we would often refer to that for counting it. Or if you like the formula, you can take the second pair's y value minus the first pair's y value. That gets you the change in y, over the second pair's x value minus the first pair's x value. That gets you the change in x. So all of these are equivalent. I will rely mostly, I think, on rise over run, because with a grid and graphing and knowing the coordinates, that actually will make things easier. So let's do the slope of, let's do this part first, US. So US, we would start, I'll do this right now in yellow. We would start right here at 1, 1, and we would count our rise, which is 1, 2, 3, 4 units. So up 4 units. And then we would go from there to the right and count our run, which is 1, 2, 3 units. And so for this, the slope of segment US equals 4/3, rise over run, up 4/3. And we want to see if that is the same as the slope of the other segment that this should be parallel to. That other segment would be the segment CM. So we're going to check for segment CM for the slope there. All right, so let's do this also in yellow. If we started right here and did rise over run, you go straight up. It looks like the same amount. It's 4. And then if we count our way over, we go over 1, 2, 3 to get to M. So this also has a slope of 4/3. So those two are parallel. So that's what we need for the first part. Those US and CM are parallel. And now the other piece we need are the two sideways or horizontal pieces. We need this piece and this piece. So I'll refresh my diagram here. We'll take out the parts that we did, and I'm going to try and leave everything else. Leave those yellow dots. I can't get rid of them as easy. So what we're looking at now is the slope of, we need to still do SM. So SM, it's just a little too close to that other. Bring that down a tiny bit. Okay. So that we need to do rise over run again. I'll do this time in, I don't know, let's do red this time. So SM, rise over run, right? We're looking at rise over run from S to M. There is no up and down at all. There's just a run over that way. So that would be a rise of 0 and a run of 4 or 5. We could count it out. It's 1. I lost a mark down here. There should be a mark right there. It's over 1, 2, 3, 4, 5 is what it looks like. But it has a 0 rise. So any 0 over anything is going to be 0. So this thing has a slope of 0. And the same thing's happening at the bottom. Slope of UC is also 0. And so SM is parallel to UC. And so that is verifying that it is a quadrilateral or a parallelogram. So we can say for sure parallelogram. We exclaim it with an exclamation mark. Okay, part B. Let me see, I'm going to clear up a few things in the diagram. I did a little bit of writing in red, get rid of that. Okay, part B is asking us to verify that parallelogram USMC is a rhombus by finding the length of each side. So just a recall on rhombus or a rhombi, the side lengths are all the same. It could be really tall and skinny, you know, like this, as long as this side, this side, this side, and this side are all the same length. That's where the corner is. I'm getting a little sloppy there. Okay, so that is the idea at play here. And so if we can verify these are all the same length, then we can know for sure it's a rhombus. Well, it's not hard to figure out SM. The length of SM, we can just count it. It's 1, 2, 3, 4, 5 units over. You just count them. And so SM is length 5. Same thing for UC, 1, 2, 3, 4, 5. So UC is also equal to 5. We need everything to come out 5 for this to do what we expect and want it to do. So now the others are at an angle. And so I will just remind you of a formula that I think you've done earlier, which is the distance formula. And so the distance formula is this thing here. Well, once I can get writing. Distance equals the square root of, and you do the difference in your x's, x2 minus x1 squared, plus the difference in the y values of your 2 points, y1 minus y2 squared. That would be for one xy pair that is x1 comma y1, and the other xy pair being x2 comma y2. Those are the 2 points that would go into that formula. And just what this is, just a quick reminder, it's like you've made a right triangle, and by doing x2 minus x1, you're getting this length here, and by doing y2, it doesn't look like a y. By doing y2 minus y1, you're getting this length here. And you're really relying on Pythagorean theorem, a squared plus b squared equals c squared, but you take the square root to get c by itself, and you're finding the length of that diagonal. And that's where the square root comes from, is from getting rid of that square by taking square roots. And the a and the b are the differences of the x's and the y's. So that's where it comes from, just as a reminder in the background of why we use this formula. But if we're going to use the formula, let's streamline this back down to the stuff that we need. Let's see if I can just erase the rest. Okay. So from U to S, if we're going to do US, that will equal the square root of, and remember my points here, U is 1, 1, and S is 4, 5. So I'm following my distance formula. I want to do the difference in my x's first. I'm going to call U my first point and S my second point. That will have it figured out for me. So that gives me the order of my pairs, right? So this one up here is the S point is my x2 and my y2. That'll always be my subscript 2. So for my x's, I start with my second x, which is from the second point 4, minus my first x, which is from the first point 1 squared. And now do the y's. Start with the second point's y, which is 5, and then minus the first point's y, which is 1 squared. And this becomes 4 minus 1 is 3 squared, and 5 minus 1 is 4 squared, which becomes 9 plus 16, which is root 25, which equals 5. Now, we already showed these were parallel, so I don't have to do anything else. I can just say CM, this one over here, it's parallel. I know that, and so it's got to have the same slope. So CM also, or sorry, they're congruent sides is what I should be saying. I started saying slope, but they're parallelograms. We've shown it's a parallelogram right here, and parallelograms have congruent sides. So I can basically rely on that work to know that if I found the length of US, CM has to be congruent, and I know that length already from showing it was a parallelogram. Okay, I took away too many marks on that erasing. Again, yeah, I got rid of one mark. I can put that one back. All right, now part C. Part C is find the slopes of the diagonals MU and SC. So we want slope of, right, MU and slope of SC. So we're looking at the diagonals. I'll put these diagonals in yellow. So we got this diagonal here. Let's just leave that one there and do it right now. So that's MU, that's this one with the yellow dot by it. We're doing rise over run again. So how about about I go with pink? And so from this point, we want to count our rise, which we can count 1, 2, 3, 4 units up, and then count the run over to here, which is out to, this point was what, 9, 5? This point down here is 6, 1. So from 1 as an x value out to 9 as an x value, I ran 8. So rise over run would be up 4 over 8. So this is 4 over 8, which reduces to 1 over 2. And then the slope of SC, I'll do that in a different color. How about we go with this other darker, kind of like a purple. All right, so this one, I'm also going to do rise over run, but this time it's going down. And how about I clear off the other lines? Just clear up that so I can see better. And I'll do this back in pink again. So I'm going, no, I'm erasing, I keep forgetting that. Put all these pieces back. Okay, and switch to writing. There we go. So rise is going straight down this time. So it'll be a negative number, and it's coming down 1, 2, 3, 4 units. Down 4, and then it's going to the right, and we can count them 2 units. So rise over run, down 4 over 2, that's a -2 slope. And if you remember things about slopes, these are perpendicular because negative reciprocals are perpendicular slopes. Exclamation, sloppy exclamation. Yes, these are perpendicular, we say with exclaim, or we exclaim, and we say it with emphasis. So the last thing is use the results in part C to complete the theorem. The diagonals of a rhombus are, well, we just said it. Part D, perpendicular. Perpendicular. Okay, hopefully that is uber helpful for you. Actually, before I come out of tablet mode, I'm going to go back into tablet mode. I'm going to shut off the video in a moment. Once I get back to the screens I should have stayed on. So if you found this helpful, that's awesome. That's why I did it. All right, so got that saved and say goodbye. Okay, there I am. Now I'm saying goodbye.